Hey, I'm Alice Egan, and this is SaaS Savvy, your online resource for thriving in the tech industry. Welcome to part 2 of this 3-part series on API fundamentals, where we will cover all things remote web APIs and the web, all curated for those of you like me who are not software developers by trade. SaaS Savvy brings SaaS and cloud technologies back down to earth so that you can sell, market, consult, and design more confidently. Follow, like, and subscribe for more approachable tech content. In part 1, we touched on various kinds of APIs out there, from APIs in programming languages and our web browsers to inside our devices. We also broke down just what software interfaces are, and we unpacked how developers use APIs to code, software use APIs to talk to other software, and human end users use APIs every time we click, tap, and swipe on our device's graphical user interfaces. In this part 2, we are going to narrow our focus to the web and the special kinds of APIs that use the web to allow two software applications to communicate. These are called remote web APIs, and we'll learn why in just a sec. You're more familiar with remote web APIs than you may think. Think about how much processing power and storage your favorite apps take up. For example, I use Allo Moves to take yoga classes on my phone. My 64 gig iPhone would not fare well with the thousands of classes it offers, but it doesn't need to. Remote APIs stream the classes from Allo Moves cloud servers to my phone instead, and nothing is stored locally unless I download a class to my phone ahead of time. If you've used Google Translate's image-based translation feature, which is really cool, you've used a remote API. It takes a ton of processing power to translate an image on screen. So Google uses remote APIs to stream the data to their cloud-based machines to do some heavy-duty processing of what you're trying to read in a foreign language. We call these kinds of APIs remote since the data being manipulated or accessed via the API is done outside of the computer, device, or browser that is making the request. And they're web APIs because they use the web to communicate. We're going to go back to Photolly, our hot new photo sharing app. At this point, we've talked a lot about how APIs are designed by programmers when building an app, and they're designed to selectively expose data and services from the underlying implementation. We've talked about how certain kind of interfaces connect the front end to the back end of an app and make it work. In the Photolly example from earlier, we saw some of these internal type APIs, like the app accessing the device's camera hardware or accessing filter code. But we also talked about the actual uploading of the photo from my Photolly app to the gallery using a remote web API to send the data from the front end to the remote backend servers. Like most web or mobile apps, Photolly's backend is stored on a series of machines in a faraway data center. And this front-end, back-end communication is done via remote APIs. These specifically are referred to as internal or private APIs, since they're used by in-house Photolly programmers who are building proprietary stuff into the app. They may, for example, build a new Photolly timeline module in the app using the API that they've exposed. And they're also likely using these APIs over a private internal network that is not the internet for faster processing or security reasons. But let's say when Photolly is in its early days, their backend is stored at a remote data center on a bunch of physical machines. But now that it's getting so popular, they're running out of storage space for all the photos. And additionally, Photolly wants to offer a facial recognition capability for photo tagging to stay competitive. But also, they really can't make any other changes to other parts of the app, like the timeline module. Everything needs to remain the same, but they need to make these changes. In a world without APIs, Photolly would need to buy more machines to store all the app's ever-increasing photo data, and they'd need to get their developers to build an AI facial recognition tool from scratch. Now, doing both of these things are possible, but technically speaking, no easy feat and not without considerable costs. Computer hardware is very expensive, as are software developers who are specialized in AI. But with open and public APIs, Photolly can find a more efficient and cost-effective solution. Instead of buying more storage machines, they can send photo data instead to a storage as a service provider like Amazon Firebase. They can sign a contract with DeepFace, a best-of-breed AI-powered facial recognition software, and integrate this into Photolly via API so that their developers don't have to build this AI tech from scratch. And these integrations Photolly can do over the internet with additional security settings, of course, but still the public internet. So in essence, APIs turn software into modular bricks that can be reused or repurposed just like Legos. Now, here are some more examples of remote APIs that you interact with on a daily basis. Travel comparison websites. Travel booking websites use remote web APIs to tap into the databases of all the hotels and airlines worldwide to aggregate them all for you to browse in one place. This same goes for any online comparison sites, whether we're talking about cars and dealerships or tickets and movie theaters. Google Maps. Tons of companies use APIs to embed Google Maps on their websites or within their apps. Uber, for example, needed a best-in-class map application for their ride-sharing service when they were starting up. Instead of deciding to divert developer resources away from building the ride-sharing app, and instead of investing money in building geolocation technology from scratch, in the early days, Uber simply used Google Maps API to embed a map in their ride-sharing app instead. From 2016 to 2018, Uber paid Google an aggregate of approximately $58 million to use the Maps API, and then they brought on their director of product management for Google Maps as Uber's chief product officer. Payments APIs. These allow for you to pay for products online with cards or payment solutions like PayPal or Stripe without exposing any sensitive data like credit card details. Banking APIs also allow for you to aggregate and view all your banking accounts from one interface like Mint without Mint having access to all of your banking details. And even within a bank, an API also handles financial transactions throughout the institution like bill payments and transfers. And finally, universal logins. Creating a ton of usernames and passwords is a pain, so lots of apps and websites these days allow you to use your Facebook, Twitter, or Google profiles to log in instead. The website that you're logging into uses an API to verify you against your social credentials and authenticate you there instead before redirecting you back to the website. So far, we've seen examples of APIs used privately at Photolly or internally within the company to connect parts of an app or to share data across the business, and this is often done over an internal network connection. We've also seen how open APIs allowed Photolly to purchase other software and integrate it into their own application, and this was done over the public internet. API availability designates how an API can be used by the API provider themselves only, or by external people or developers, or by specific partners. APIs can be private or internal, meaning they are designed to be hidden from external users. Some internal APIs are designed to allow different areas of a business to consume each other's tools, data, and programs. Other internal APIs connect the front end to the back end, and in other videos we'll talk about microservices architecture, where a large monolithic application is broken up into more manageable decoupled parts and use APIs to communicate between the various parts of an app to make a whole. Open, public, and partner. So APIs can be open, and this means they are available to people outside the company. You'll often see open APIs referred to as public or partner, and really what the difference boils down to is just how open it is. So how much of the API is available to anybody, and if it's free to use, no strings attached. I'm not so hung up on the difference, as I really see it as more of a spectrum of just how open any open API really is. So for example, the weather API is open and public, and anybody can use it to pull from large databases of weather forecast information. The US government makes data like the US Census Bureau citizen data available via their API. And web browser APIs that make it easier for developers to create web apps that are compatible with different browsers from Chrome to Safari to Opera are also free to use. And moving into the partner sphere is kind of gradual. For example, SaaS providers like Zendesk and Salesforce have open APIs that anyone can use, provided you at least start an account and register before accessing the API. Specific parts of the API and the functionality that go along with it are gated to specific pricing plans. Then there are companies like Twilio or SendGrid that are purely API products. That's all they sell. So in order to use their APIs, you've got to create an account and pay for access. And a true partner API is an API that two business partners may develop or use in tandem. For example, let's say Asana and HubSpot decide that they want to make a really strong integration together to attract more customers on both sides. Asana may open up a special API that no one else but HubSpot will have access to so that they can build this integration the way that it needs to work, and they won't make that API or functionality available to anybody else. There's a business contract in place here before this partner API is designed. Basically, internal APIs are used within a company and within that company's products or across applications. And open APIs are made available to others on a spectrum of everybody to specific parties, entirely for free or for a fee. Twitter has long since made their API open and available for use to the public, but more recently they've updated it to offer more data sets and charge for different levels of access to it and for different purposes. So here are some successful use cases of the Twitter APIs across industries from an open, public, and partner perspective. So number one, customer insights. In the early days of Twitter for business, brands could fall prey to sudden Twitter storms of unhappy tweeting customers. Now, Co-op, one of the UK's biggest food retailers, has built applications that use the Twitter API to get insights into their customers and even potential crises before they happen, but also for long-term analysis. For example, sourcing food ethically is Co-op's company credo, and their food policy team wanted to understand which ethical issues Co-op customers keep top of mind. The food policy team used Twitter and Twitter's API to track subjects like sustainability and ethical trading, and their insights shape how they work with farmers and approach various policies that shape how Co-op sources and buys their stock of food products. Build for public good. Hate Lab is a global hub for data and insight into hate speech and crime. Hate Lab's dashboard uses machine learning and data sourced from the Twitter API to power learning into how and when toxic conversation flows online. This data helps guide charities, government departments, and other organizations on how to respond and support their communities. And finally, scientific research. During the COVID-19 pandemic, Twitter actually built a COVID stream API endpoint and unique data set covering tens of millions of tweets daily and offered insight into the ever-evolving global public conversation. They opened up the COVID-19 Stream API endpoint to 100 scientific researchers and developers who were able to use the data to research the spread of the disease, understand misinformation, develop machine learning and data tools that could help the scientific community answer key questions about COVID-19, and much more. At this point, we've talked about how remote APIs work over an internal network connection or over the public internet to exchange data. As we inch towards our final video in this series, which covers the web standard REST API, the most prominent API of our time up until now, it's important to realign on a baseline understanding of how the web works. When it comes to understanding how web-based SaaS applications use APIs to connect to other software and integrate, an understanding of web fundamentals is a must. So let's take another high-level but informative overview of core web concepts. We're going to start by briefly talking about the difference between the internet and the web, because it turns out they are not interchangeable. The internet is a global network of servers, computers, and other hardware devices. This interconnected network of computers and servers goes back to the 1960s when US government agencies were looking for a way to share military information to each other. Devices on the internet connect to others as long as they have a valid Internet Protocol or IP address, and today you use the internet to access the web. The World Wide Web, or the web, is like an application for the internet, and it was invented by Sir Tim Berners-Lee in 1989 so that research scientists could share documents with each other over the internet, or over an internet connection. These documents morphed into web pages, which then morphed into the advanced web applications of our modern age. So you use the internet to access the web, and all the stuff that you access on the web, websites, web apps, photo sharing, music streaming, are part of the World Wide Web. And all this information exchanged on the web is done via a protocol called HTTP. The internet is a giant network of clients and servers. Client devices, computers, laptops, phones, make requests to servers, which are special computers configured to process requests from clients and respond to them with information over a network. When information is shared and accessed over the internet network, as opposed to a local network like one in an office, for example, it can be viewed on the web. Even if it's gotten much more complex today, client-server architecture remains the backbone of the entire internet. The client is the device where humans interact with the front-end UI. All applications are built with code that is hosted on the computing machines at the back end, i.e. the server side. And servers contain resources that clients request. Resources are anything from a document to a web page to a file. In SaaS applications, resources are basically anything that can be named, and they usually take the form of what the business does. So a contact in HubSpot, a photo in Photolly, an order on Amazon, or a chat on LivePerson. Let's take a very simple example of a restaurant website that simply displays information. Here's the address, this is the menu, look at this delicious chicken. It's more or less a static bunch of text files, layout and color files, and images. On my client web browser, I type the URL of the restaurant into the address bar. A universal resource locator is the unique address on the backend server where this resource, the restaurant webpage, is located. My backend server lives in a remote data center somewhere in the world connected to the internet. When I hit enter, my client browser makes an API call using the HTTP protocol to the server. You can think of HTTP as the contract between client and server that lays out how they'll send and receive data to each other. HTTP is all about resources, and the nice thing about HTTP is that it includes a select few verbs that the client can use to tell the server what it wants to do with the data that it's asking for. Since we just want to view this website, we'll use a GET call to ask the server to send it back to us so that we can view it. The server locates the resource on its URL. All good. The server makes an API call back to the client using HTTP. The client browser has been designed to render all the data and files into the web page that I see here on the front end. And when I click a link on the web page like gallery, another HTTP GET call is made over the internet to the URL of this hyperlink, and this cycle continues. But with web applications like Photolly or HubSpot, we're dealing with a lot more than just text and colors and files on a page. In a web app like HubSpot, we're dealing with many different resources inside the app, like companies, products, and contacts. We might need to not only access and view these resources, but also modify them over time or delete them. Web apps follow the same client-server architecture, front-end, back-end paradigm that we've already talked about. Just like websites get URLs, resources in web applications get their own versions of URLs called Universal Resource Identifiers, or URIs, so that they can be easily located and accessed and modified as part of an application. For example, in HubSpot CRM, I might want to open up Contact 201 on my screen, but I also might want to update his email address or delete a phone number on his contact record. As a HubSpot user, I click on my user interface to do all these things, but behind my screen, API calls are firing like crazy. HTTP sets out a number of different verbs that clients can use to communicate what they want to do with any given resource in an app. These are referred to as CRUD because they allow us to not only view a resource, but create, read, update, or delete it. So the internet is based around clients and servers talking to each other over HTTP, which allows clients to state what they want to do if they want to get a resource on a web application. When an API call is made, these verbs allow an app to dictate what should happen to the resource, i.e. if a contact should get updated, if a ticket should be created, if a comment should be deleted, or an email address added. And that's it for now. So we'll quickly recap part 2. Remote APIs are integral to an application working at all, and being able to send data or fetch instructions or processing power from a faraway machine in a data center. When remote APIs are used internally, this is often over a private network. When companies offer open APIs in their products, this turns software into a bunch of modular Legos via the power of the greatest network of all, the internet. If you can't build it yourself, you can integrate another software into your application to take advantage of best-in-breed software or honestly just cut corners in the development process. The internet is the giant network of clients and servers, and the World Wide Web is what we use to interact with all things on the internet. The HTTP protocol is the contract for communicating between clients and servers, and it contains a few verbs that clients use in their API calls to servers that indicate what it wants to do with the resource that it's requesting. Resources are anything from an image to a document to a web page on a URL, or something inside a web application that can be named, like a company, product, or contact if we're talking about something like HubSpot. And these resources become endpoints on an API. Thank you so much to my sources. Again, these are included in the video notes. And coming up in part 3, our final video in this API series, we'll cover the internet's gold standard REST APIs and how they leverage the power of the internet to be the most scalable and flexible of them all. Well, at least for now. Thanks, and I'll see you there.